In this video, we're going to explore the differences between standard form of a quadratic equation and vertex form of a quadratic equation. Now, the whole point of what we're trying to do here is take a look at which form would be easier to interpret the function. So on the left-hand side, we have equation 2x squared minus 4x plus 5. And on the right-hand side, we have the same equation but written in a different form. This is in standard form. This is in vertex form. So what we want to do is figure out, based on the forms that we have, which one is easier to find some key pieces of information. Well, the domain, it really doesn't make a difference. We can use form A or form B, the standard form or the vertex form. The domain we know for quadratic equations will be negative infinity to infinity. So yeah, we're not worried too much about that one. It could be either one. The range would probably be easiest to determine if we could visualize what the graph looks like. In my personal opinion, I think vertex form is easier to work with in that case because it's fairly easy to pick out where the vertex is and then to figure out how it opens. And then from there you can figure out the range. So based on that, I think B would be an easier form to use. Increasing and decreasing tells us if the graph is going to open up or down, or where it opens up or down. I'm sorry, not where it opens up or down, but if the value is getting bigger or smaller for the function. So based on the fact that we need to know the vertex, I'm thinking that vertex form, which is form B, would be much easier to use. And if we're trying to find the vertex form would certainly give us the vertex more easily. Direction of opening, it really doesn't make a difference here because you've got this number in front of the x squared. Those are both the same. So really either one. And the value of the y-intercept, this is one where I think standard form really shines. In standard form, the value of the y-intercept is when x is 0. So when we plug in 0 here and here, these end up zeroing out and we're just left with 5. It's very easy to calculate the y-intercept because it's just right there. Versus vertex form, where we have to take 0, subtract 1, square it, multiply by 2, add 3, and eventually we get the same thing. So for that, I think the standard form, which is form A, is more beneficial. Axis of symmetry is related to the vertex, so again, if we can easily pick out the vertex, then the axis of symmetry just falls in line. So 8, I would say axis of symmetry, the vertex form would be easiest. So hopefully from this you can see that the vertex form probably has more value to us in being able to not only sketch the graph, but interpret what the graph of the function would actually look like. What is it doing? Is it increasing? Is it decreasing? What values of y can we get? The only one that I'm seeing a clear winner for the standard form is the y-intercept, but everything else seems to be vertex form. So what happens when we get an equation that's in standard form, and then they're asked to find the range, the increasing, decreasing, all that sort of stuff, vertex? What do we do? Well, we're going to need to convert. And we're basically just going to work through some examples on how we're going to do that. Now, our goal is to get something that's in vertex form. So what we want to have is a quantity related to x that's been squared. We also want to figure out what our vertex is going to be. Now, to do that, what I'm going to do is take a look at 2x squared and 12x. I'm going to ignore the 22 for now. It's just going to kind of be there. But I'm going to take a look at those two. And what I'm going to do is factor out the greatest common number factor. I'm not worried about the fact that they're x's. I just want the biggest number that they both have in common. And in this case, with a 2x squared and a 12x, my biggest number I can take out is a 2. And when I do that, I'm going to be left with x squared and 6x. And I'm going to leave some space because where this is going is we're going to take that quantity and we're going to need to complete the square for it. If I don't have some space there, I'm probably going to forget to complete the square and I'm going to be lost on what I'm doing next. And then I've got my 22 that, again, is just kind of come along for the ride. So my next step then is to complete the square for this quantity inside. And again, I'm going to use the area model because, again, I just think it really helps in organizing that information. So my first term has got to be an x squared, so that's an x and an x. And I've got a 6x, and if it's a true completed square, that means that the factors are both going to be the same, which means that these numbers have to be the same and these have to be the same. But they have to add up to 6x. Well, for that to happen, they both have to be 3x's. And if these are 3x's, and these are x's, then these must be 3's, which would then make this a 9. Now, that 9 is going to go in that parenthesis because it will complete the square. Here's where it gets a little bit weird. I introduced that 9. That was not part of the original equation. And I can't just do that. I can't just put numbers into an equation and not change its meaning. If I were to graph this original one versus this one, they would not be the same graph. Well, they have to be in order for the process to work. So I want to figure out, how can I adjust this? I can't just randomly add a 9 in and not adjust it. But here's the weird part on this. That number is not actually a 9. Yeah, okay, it's a 9 here, but there's a 2 out front. So in reality, that number that's represented by a 9 is actually an 18. So what I did, and I figured this out from this 2 times 9, what I did is introduce an 18 that wasn't there. I need to balance that out. So if I introduce an 18 that wasn't there, I'm going to have to subtract an 18 to account for that. At this point, I'm ready to factor. The good news is the factoring should be relatively easy because we've actually already done it. F of x is 2, and then the factors can be found from over here, from the area model. X plus 3 squared. And then 22 and negative 18 will give me 4. Now what could happen is I could take that equation that I've got here. This is in vertex form. This is in standard, so I'm going to write that standard. And then vertex. If I graph this versus graphing this, they should overlap completely. They are the same equation, just in a different form. And I can also verify that algebraically I can distribute this out, multiply by 2, add 4, and I should get back to my original. So this is my form in vertex, or my equation in vertex form. I can easily pick out the vertex, how it opens, increasing, decreasing, all that good stuff from the vertex much more easily than from standard form. So that's when we're taking a positive number out. Let's see what happens when we take a negative, and some weird fun stuff happens here. So I'm going to take out here. I'm looking at those two terms. And you might think the common factor is 4, and you're technically right, but our goal is to get an x squared, a 1x squared. So we don't want any negatives, we just want positives. Well, to make that happen, we have to take out a negative 4 from everything. So I'm taking out f of x equals negative 4 times x squared. And here's where we got to be careful. When I take a negative 4 out of here, if I take 16 divided by negative 4, that's actually a negative 4x, not a positive 4x. Not a huge deal until we get to the area model and find out that if we didn't make that a negative 4, we're going to factor it incorrectly. We don't want that. Again, leave some space so we can complete the area model, and then we've got 19. So let's complete the square. And again, we have an x squared. There it is. X and x. And we want the same factors. We want them to add up to negative 4x. So they have to be negative 2x, which means this is a negative 2 and a negative 2, which gives me this as 4. So I'm going to add a 4 into here. But again, that 4 is not a 4. It's a negative 4 times 4. So this right here is actually a negative 16. Now, I introduced that wasn't part of my original equation. I've got to balance it out. So if I'm randomly, or not randomly, but strategically placing a negative 16 into the problem, I have to balance it out by adding a 16 on the outside of those parentheses, because negative 16 plus 16 will cancel. And at that point, I can go ahead and factor, and I've got f of x equals -4. The factoring has been done over here. It's x minus 2 squared, and then that would be -3. Again, vertex easy to pick out. It's 2, 3. I can tell the range, increasing and decreasing, axis of symmetry, all fairly easily from the vertex form of an equation. So factor out the greatest common numerical factor from the x squared and x terms, complete the square, balance it out, and that's what we're doing here in that red step, and then factor to get it in vertex form. That's how we're going to convert from standard form to vertex form.